A data center is a facility that houses Yahoo's computing infrastructure, including servers, storage, and network devices. A data center is often referred to as a colocation or colo. To give you an idea of the scale of our data centers, we now manage over 250,000 servers, over 50 megawatts in production, with capacity of over 75 megawatts of power. Yahoo has data centers on every continent, except for Africa and Antarctica. But how does a data center work exactly? And who are the people who work there? Meet Andre Rico, Chief Facilities Engineer at Yahoo Data Centers.
Let's say you're an electron traveling through the data center. Where would you go? How would you get there? Let's find out. The primary switch gear, or PSG, is where the utility service enters the facility. The PSG is served by two separate utility services for redundancy. Medium voltage transformers convert 12,000 volts to 480 volts, which is delivered to the main switchboards as usable power. Here you can see one in an electrical room where the main distribution and power systems are located. In case there is a problem with power transfer or when there is an outage to repair in progress, several 2 million watt generators are attached and coupled to 3,000 horsepower diesel engines. The diesel generator set is designed to provide power to the main switchboard at 480 volts during any kind of planned or unplanned utility outage. Each generator can operate at full duty for extended periods of time dependent on the amount of fuel on hand. The uninterrupted power supply, or UPS, is a system that keeps the servers powered during the initial transfer from utility service to generator supply. During a utility outage, the load is transferred to the UPS system until the generator system starts and provides the voltage and amperage to the main switchboard. The UPS does not carry mechanical or lighting loads during the transfer or during normal operations. The main switchboards are the central location where power is received and distributed to the critical or essential loads. Located on this board is the utility input breakers, diesel generator input breaker, swing generator input breaker, numerous UPS output breakers, and essential loads like cooling and lighting. A power distribution unit, or PDU, transforms power from 480 volts to 120/208 for distribution to the remote power panels, or RPPs. This system consists of a step-down transformer and numerous distribution breakers. The individual 30-amp breakers provide power to the boot boxes located at the cabinet level. From there, the servers are plugged in to provide power to each server. Each boot box is managed and redundancy is maintained. The cooling system provides cooling to the data center by utilizing chill water distribution and evaporative cooling towers with chillers that provide mechanical cooling. Air distribution is provided by outside air economization or air recirculation completed by the installed CRAW units. Fire systems provide protection by a dual interlock dry pipe pre-action system. This system allows pinpoint fire protection while keeping water out of the data center until an actual fire is present. Got it? Let's move on to boot boxes and cabinets.
Yahoo cabinets are built out at our factory, which is located in Portland, Oregon. The factory is where orders are shipped, where inventory is stored, and where installations are prepared for deployment. Our dedicated Yahoo trucks are used to move equipment from the factory to the data centers within the US, as well as moving equipment from colo to colo. Each cabinet that is built out at the factory and deployed into our data centers are customized with a rack switch, console for remote access, and smart power strips for bootboxing servers remotely. Cables are color-coded purple for network and yellow for consoles. Uplinks for each rack switch are connected back to the core switch, also known as the BAS switch, via copper or fiber connections. We run half the uplinks to BAS 1 and the other half to BAS 2 for redundancy.
OpsDB is important to us in the data center because it allows us to, well, first and foremost, find where the machines are located. OpsDB is a homegrown tool, and it has all of the location information for all of our assets in the data center. It allows us to find by site, by row, by rack, and by shelf. So renaming machines out of process causes a lot of extra work on the data center team. It's really kind of a Where's Waldo effect. You get a machine that has no home, essentially. It's just got a name. You know it's in this building, but you don't know exactly where. And when we're talking about buildings that are 20,000 square feet, tens of thousands of machines, it becomes problematic.
We need properties to plan in advance. If they know they need to migrate servers from one particular backplane to a different backplane or from one co-location to a different location, we just need them to keep us in the loop in advance. We can always do it, but doing it overnight necessarily isn't the best answer to the situation. So, we need properties to kind of loop us in early, so we can plan ahead, so we can get the re-IPs done, so we can get the space and power figured out. Then we can proceed forward with the migration smoothly.
The installed security system allows for detailed security review of all areas of the data center and all entrances and exits. This allows monitoring by local security staff as well as by mission control. All video is backed up off-site to allow review of any film as required. The centralized system allows security staff to see data centers in various locations.
So at a company with good security measures already in place, why do we keep some servers separate from the others in an area we call the vault? Well, the devices that we keep in this area contain confidential customer information, such as credit cards and tax ID numbers. A number of laws and regulations dictate this level of security to ensure that we remain compliant with their standards. Tiles are bolted shut from underneath, and access is granted and monitored through mission control 24/7. Security cameras capture every inch of the vault. An additional layer of background check is also required by the SiteOps techs to gain access into this area.
The Yahoo Data Center security system is very robust. Regular Yahoo access badges do not even work here. At all Yahoo data centers, only qualified Yahoo staff are allowed to complete any switching of any breaker or system operations. Completing this with Yahoo employees ensures that all processes and procedures are followed in detail and limits any outside failures due to lack of system knowledge by untrained personnel. Each switching procedure is located at the equipment room door to ensure that it is always available when needed. The on-site local data center facility staff conducts very detailed and extensive rounds on every piece of equipment every day. Yahoo Data Center Operations is also transitioning from paper rounds to a more electronic-friendly system that is also in line with our green initiatives.
CMS is a change management system. Anytime you open a change management request, whether it's a simple request or emergency request, you have to open it to the correct region to include SiteOps support.
When submitting a SiteOps ticket, please open up the request via the service catalog. The service catalog will auto-generate a ticket number for you. At the bottom of the ticket, you can find the service level agreement, or SLA, to give you an idea of how long the request will take to complete. While we always try our best to complete tickets as far in advance of the SLA as possible, please understand that the stated SLA is officially how long we have to resolve the issue. If your team cannot wait that amount of time for the request to be completed, you can ops escalate the ticket through the service catalog under the tab called Escalation Form with its need by date. However, use this function sparingly and for legitimate issues only. Properties don't necessarily know the amount of physical work involved in it. OpsDB has to be updated, we're recabling stuff, we're moving those servers physically from one place to another. So, if you can imagine doing that for one server, multiply that by 50 or how many servers that they're requesting, then you can kind of imagine how time consuming it might be.
The valid reasons for it is getting paged if it's revenue impacting, or a switch goes down, DOS attack, something that dramatic happens inside a data center. Everything else should be handled to the service catalog.
In early 2005, the Yahoo data center footprint was housed in outsourced third-party colocation facilities. These facilities were built during a time when data center efficiency generally wasn't a core focus in the industry. Our footprint at the time consisted of several tens of thousands of servers. Our footprint has grown more than 10 times since then. Our host count is now in the multi-hundred thousands.
Building our own data centers lets us control our own destiny from timing, scalability, capacity, and risk perspectives. One newer facility is in Washington State, also known as GQ1. Since 2007, we've grown from dirt to over 66,000 hosts and 12 megawatts in central Washington. So far, this is our lowest cost data center. It uses the new patented YTC cooling technology. In this site, YTC saves enough electricity to power over 500 average households. This increases the size of GQ1 to 15 megawatts of critical capacity. This site alone could now accommodate as many as 100,000 hosts.
Another new data center is NE1 in Nebraska. It is the first site built with the new flat network architecture. This facility's footprint is almost 300,000 square feet and has almost 6 acres for expansion. At NE1, we use the new active power units. It is a greener solution than battery UPSs and allows maximum flexibility and reliability. Also, it is more efficient than traditional battery-based UPS systems.
In August 2009, we broke ground on a 9 megawatt phase of our Lockport, New York site called BF1. This data center will allow clean, affordable hydropower from the Niagara and is built on available, affordable real estate. Using previous generation water-cooled chiller plant infrastructure, a typical 5 megawatt data center can require as much as 125,000 gallons of water per day and over 20 million gallons per year. Sewer discharge can total over 2.8 million gallons per year. Our Lockport, New York cooling design, the patented Yahoo computing coop, nicknamed Yahoo Chicken Coop, eliminates sewer discharge completely and requires 10 times less water than the previous way of cooling. Thanks to our new design, enabled by Lockport's environment, we've been selected as one winner of a $10 million Department of Energy grant related to innovation in energy conservation in the United States.
Some of the innovations at the data center have been the rolling cabinet, which has allowed us to grow from 2,000 to 10,000 hosts per month. Before the rolling cabinet, traditionally servers would come in on pallets in big boxes, lots of foam, lots of garbage that we'd have to discard. The rolling cabinet is a much greener solution, Yahoo being a green company. Well, it's a lot greener due to the fact that we're able to cut fuel costs, delivering multiple cabinets to several locations in one truckload as opposed to receiving several deliveries from who knows where, by plane, by freight, by truck, all across the country and from different countries. We discard a lot less waste with the rolling cabinet. Before the rolling cabinet, traditionally, we'd have to physically lift each server, slide it into the cabinet, bolt it into the cabinet, and you're talking thousands and thousands of hosts or servers. The rolling cabinet is pre-integrated, meaning that it comes from our factory up north, pre-wired and pre-stacked. There's no cabling involved when it comes to the data center, except maybe plugging it into the receptacle and maybe running a cross-connect. Regarding efficiency retrofits in our legacy data centers, cold row encapsulation and precise temperature monitoring with variable control of computer room air handlers or CRAH fans adds up to a major savings in power. In 2009, we received the Silicon Valley Power Innovators Award at Stanford University. It saves over $500,000 per year in previous electricity costs. These trends add up to lower costs, higher performance, and high efficiency, especially compared to our legacy data centers. Our data center costs are half to over 4 times lower in Yahoo-built data centers through various innovations. As you have seen, a data center is vital to the life of Yahoo as a technology company and to your role in making sure data and properties are functioning at the highest capacity and lowest cost. You can have it all.